The goal of our design is to help control excess runoff coming from farms. The design will be engineered to be universal, cost-effective, and also safe for the environment, and will also utilize an alert system. For my design, I will implement filters to block runoff and send it to a reservoir to either break it down completely or return it to a recycling tank. My design will also be made with many different separated parts in order for it to be interchangeable depending on the application. In order to be cost effective, my design will use plastic for the recycling tank and the reservoir. The filter system will utilize mycelium, since that is a biodegradable material for when there just so happens to be a natural disaster and the filtration system becomes destroyed. After the dam, there will be sensors added in order to monitor the percentage of nitrogen in the fresh water coming out to make sure the system is functioning properly.
My design will utilize an underground irrigation system to provide water and nutrients for crops on farms in order to decrease farm runoff. My design will include a soil moisture sensor to provide water and nutrients for the plants when they need them, so there is no excess nitrogen in the soil. The pipes will be made of low-density polyethylene, which is cheap, flexible, operates with low pressure, and leaks well.
My design will have two borders to prevent fertilizer runoff into water. The first border will consist of wood and the second one will be made out of concrete. I'm having two borders because concrete is a water resistant, but it has high pH level, so if it's mixed with the plant soil, the plants don't get enough nutrients, so by adding a wood border, it will solve this problem. Also, I will have sensors inserted in order to determine water level and nutrients so that there won't be too much water or fertilizer in the soil.
My idea to control the nitrogen cycle is to implement water purification systems at several stops along the main bodies of water in Florida. These purification systems will have mesh and nets to protect wildlife from going into the tank. There will be pipes that lead from the waterway down to an underground tank. Along the way, the falling water will turn turbines that will produce electricity that heat the tank. The tank will then produce steam, and the pressure from the steam will travel upwards through exit tubes that lead back to the main waterway. The pressure from the steam will also turn secondary turbines that will also power the heating of the tank. There will also be solar panels at the ground level that will also aid in heating the tank.
Our final design will be a dam system that utilizes cost-effective material and parts such as mycelium, polyethylene, wood, and concrete. There will be plumbing implemented to bring back nitrogen to be recycled or completely broken down. And there will also be sensors to help control excess nitrogen that might be coming off of the dam.